In this section, we're going to talk about some service-side considerations. These are kind of polish that you can add to the service, but really should be done so that you can manage the service better and work with your clients better. This topic will talk about throttling client requests. Services must fail fast if requests are greater than some quota, where a quota represents some number of requests per unit of time. If the server is overloaded, then it should return a 503 service unavailable to the client. Most client applications will wait some period of time and then retry the operation again, usually using some kind of exponential backoff pattern. If a particular tenant exceeds their quota, then you should return a 429 too many requests. Also, when you're returning either of these, it's ideal to include a retry after response header that specifies the number of seconds that the client should wait before it retries the operation again. This way, the clients don't spin and make extra I/O requests against the service, actually bombarding you even more and putting more pressure on the service than is necessary. Of course, clients may or may not actually honor the retry after, but they can't honor it at all if you don't return it back with a good value. Another thing to consider is customer support. Because clients will be making requests, your service will be returning responses back, and it could be you have a bug in the service and the client doesn't understand the response it received. In that case, the client may contact customer support and say, hey, made this request and I got a response that just doesn't make any sense to me. For services to have good customer support, the service must assign every request a unique ID when that request comes into the service, and then log the ID along with the request information in some kind of log file, and then hold on to these logs for some period of time. The period of time is, of course, determined by you owning the service because you may have to be paying for the storage of this data. But the longer you can hold it, the better experience you can give to customers. I know some services that hold the information for only a day or two, and if the customer reaches out to customer service for support beyond that period of time, then customer support won't find the entry in the log, and it becomes very difficult to help a customer to sort out their problems. When the service goes and creates this unique ID for the request, it should then include that ID in a response header that comes back to the client. And on Azure, we use the XMS request ID header with that ID. Because these are unique IDs, they usually are GUIDs or UUIDs is what's being sent back. But they don't have to be. It can be any value that is useful to you on the service. Most of the time, the client is going to ignore this response ID header. But if the client receives a response that doesn't make sense to them, usually during debugging or testing, then the client may get on the phone with customer support for your service and then can say, or send an email, and then the client can say to the customer support people, this is the request ID that I'm talking about. I sent it on this date and time, this is what I sent, this is what I got back, and it just doesn't make sense to me. And then people who work on the service can go to the logs, look this up, and try to understand what actually happened more. When services get requests from clients, those clients can be running on different operating systems, different versions of those operating systems. The clients can be written in different programming languages and different versions of those runtime engines. And it's very nice for a service to be able to get some information as to about what are the kinds of clients that are calling into the service. We call this telemetry. And all of the Azure SDKs, they send telemetry to the service by way of an XMS user agent header. And so services should be looking for this header in the request, and whatever string is there, that should be written to some log as well. And if that header is not there, then the service should be looking for a user agent header and write that instead. Now, in Azure, we have a common format for these strings. And the string format goes something like this. There's an optional app ID. So the application itself that the user is writing can actually amend this string and put the name of their application in the string. Then for Azure SDKs, we say AZ SDK dash and then the SDK language, like C or C++ or Go or .NET or what have you. Then a hyphen, then we have the name of the language package, a slash, and the version of the package, and then we have the platform information. So I show 4 examples below here of an application called AZCopy, and this happened to be for version 10.0.4 of AZCopy. So AZCopy was an application written by a customer, and it was version 10.0.4 that was using the client libraries that are making calls into the service. And then it was using the storage blobs client library for .NET, but AZCopy could also run on, could be written in JavaScript, or it could be written in Java, or it could be written in Python, and then it would use that storage blobs package that's appropriate for that language. And then it was using version 11 of all of them, except for the Python one, which happened to be a version 4. And then the platform information at the far right, like .NET Standard 2.0, running on Windows NT, 10.0.14.393. So this is information that is sent from our client libraries in Azure up to the service, and customers could send this to, the service can accumulate all of this information. The Azure services then log these values, and so that these values can be queried by various analytic systems. So now you could ask questions like, so how many customers calling into me are using .NET Framework? How many customers calling into me have written their code in JavaScript? What application is calling into me? What version of that application? We had a bug in a certain version of a client library, and we haven't seen in the last several months any requests from clients using that buggy version. That's good. They've all upgraded to the newer version, right? Those kinds of things is what this telemetry can answer, and it's very useful. We also support the ability for clients to send per operation. So these headers I mentioned before, user agent, those are sent with every request. But from the same client library, it would be the same exact value every single time. It may be that for some specific operations, you would like to include some additional information. And we do have another header for that. It's XMS AZSDK-telemetry. And here you can say class equals and the name of some class or structure or data type that's in a client library. Like this example here is using the blob client. And then method equals and the name of some method or function that's part of that type. And then you can have additional key value pairs as part of this string. Again, the service, all it does, it log this. But now you can do your analytics questions and say, so for a particular method, how many times is this method being called in this language versus this language and with whatever version of a client library? And that method is of what class and what other parameter maybe. So in this case, I'm showing blob type equal block. So this is downloading files into block blobs heavily, right? So if you see a lot of this, it really gives you a lot of insight into how clients are using your service. And now we'll talk about adding distributed tracing. Distributed tracing is a newer feature than some of the others. And the idea behind distributed tracing is that the user initiates an operation, and that operation goes to one service, A. Service A then talks to service B then talks to service C, and so on. And you would like to be able to trace the originating user request between all of these services. And typically what gets recorded is which services are called and how much time it took for each service to do its work. So if ultimately you give an answer back to the customer and you say, well, it took a second, then you could say, well, service A was 1/3 of that, service B was half of that, service C was the remaining time of that, and then you could know how to optimize based on that. And that's what distributed tracing is useful for. And clients who are using Azure services, we want them to be able to include the distributed tracing information in their requests, and we want the Azure services to be able to take part in this tracing mechanism. So it produces request tree of causally related events. And it can answer questions such as, what services did a request pass through? What occurred in each service for a given request? What spans, which is a fancy word for saying sub-requests, are performance bottlenecks in handling a request? How much time is lost due to network lag? That's the real value that is obtained by using distributed tracing, or when customers leverage distributed tracing, but our Azure services also participate in this. For more information about distributed tracing, you should see the W3C technical report, and I put the URL of it on the slide. Also, you could look at Open Telemetry, which is sponsored by the Cloud Native Computing Foundation, and I put a link there as well for more information. Now for you on the service, what this really means is you should be expecting in a request to your service 2 headers. There's a trace parent request header and a trace context request header. And I show in the bubbles here, the red bubbles, what the various pieces of this mean. But for the most part, you should read about this, you should log it, and then if your service goes and talks to another service, you might want to modify these values, and when your service sends a request to another service. So you're passing along the trace parent and trace context, but possibly slightly modified when they go to the other service, and that's how this whole thing will be kept track of.